All right, welcome back. So yesterday, Monday's class, we looked at one of the 5 types of chemical reactions. We looked at decomposition. Decomposition is when you take a single compound, and all of these on this slide are single compounds. We have ionic, we have hydrate, and we have an ionic with a polyatomic. We are going to predict the products for these reactions. So I mentioned at the end of class yesterday for you guys to try these. So let's see if you guys did this. Or well, I mean, we'll just check your answers. So A and B are quite honestly the easiest ones here. Pretty straightforward. We would have magnesium metal and fluorine gas. Oops, that's a solid. I know that the magnesium is a solid, and I know that the fluorine is a gas because they're on the periodic table. Magnesium is white on the periodic table, and fluorine is in that pink square. So I know the phases of elements using my periodic table. You'll notice that this is actually already balanced, so I don't even need to balance this equation. So this is a pretty good and easy decomposition. Okay, let's look at another one. Let's look at the hydrate. Again, hydrates are very easy. What happens is you usually heat these up. So over a hot plate or a flame from a Bunsen burner, I would heat this up and it would split the elements, or I should say split the compound into the solid hydrate. Now, again, I mentioned this yesterday. This is like putting wet clothes into a dryer or hanging them outside to dry. The water evaporates. So I get the water product, and I can keep my numbers in front. I get the water product as a gas because, again, to decompose a hydrate, it requires a lot of heat. So I heat this up really, really hot. Literally, the water boils away, and that's how your dryers work. Your dryers will boil or evaporate the moisture away from your clothing. Guys, I'm getting a lot of feedback on the mics. If you have any questions, just put them in the chat. All right. So there we go. That's it. Now, this one can be a little bit more challenging on the bottom. Okay, this is a decomposition with a carbonate. And actually, in my other class yesterday, I had a student bring up something really, really clever, a good way to think about this decomposition reaction. When a carbonate decomposes, the carbonates are very unstable. And they will typically decompose with heat to form CO2 gas. So the student the other day had this really good idea. They said, well, if the CO3 decomposes into CO2, then just remove that from the chemical. What I mean is I would be left with calcium and 1 oxygen. It's still solid. We're not adding any water to this. And then I would add the gas that escapes, CO2 gas. Okay, pretty straightforward. All right, cool. So that is decomposition. The first 2 are definitely ones that you need to know. They're pretty easy. Now, your test this week is online, which means you can use your notes, and that should really help you with this. The other thing with your test is a lot of the questions will typically be fill in the blank or multiple choice. So if you need to look at this question, or if I asked you what type of reaction is this, the one on the top, you would just say decomposition. Okay, so let's look at our next type of reaction. We might not get every reaction done today, but I'm hoping tomorrow to do a bit of a review. So whatever we need to finish off, we can do tomorrow, and then we'll do review for your test. So this is the second of 5 reactions. This one's a little bit easier to deal with. Combination reactions are the opposite of decomposition reactions. So the idea is in decomposition, one chemical, one compound, one molecule breaks apart into 2. In combination, which we also call synthesis, the 2 chemicals come together to make a larger compound. There is only one product. So the difference between a decomposition and a combination is decomposition has one reactant, combination has one product. We're putting things together. So this is also called composition or synthesis. Just the way I did school, I guess my teachers, professors, they usually said synthesis. So if you hear me say synthesis, I mean combination. Okay, so when your reactants just have 2 elements, straight from the periodic table, they will get together to combine to form a compound. This is really easy because this is review from chapter 3. If I asked you to write the compound between sodium ion and oxygen ion, sorry about my oxygen there, right? You guys would know how to do this. We would do the crisscross method that we learned in chapter 3. I would know that my formula is Na2O. And this would be a solid. You can check your solubility table for this. The other thing is there's no water here, so this wouldn't be aqueous as well. So you can use your solubility table, and it would tell you that any oxide is a solid. The solubility table is, of course, in your data book. For you students who missed this stuff, this was back in chapter 4. So, anybody who missed a couple of classes, you might we're really building everything we've learned from chapter 3 and 4. So it's pretty important that you guys review your notes if you're confused. So, yeah, that's it. So when your reactants are 2 elements, they form a compound. If the compound is ionic, which is what we'll do in chemistry 1121 or 1120, sorry, use the ions charges to find the formula. If it's covalent, you'll need more information, which means it's not something you would see on a test. You need some more information there. I would have to tell you something, or we'd have to use a book, not the data book, but another book. So really for this course, we're going to be dealing with ionic combination. Okay, so that's it for combination. We're just going to practice this. Actually, what I think I'll do is I'll give you guys maybe 2 or 3 minutes. Why don't you try these? Okay, make sure they're balanced. I think especially for B, you're going to have to balance it. So I'll give you guys a couple minutes to try these, and then we'll move into combustion. Again, combination is a lot easier than synthesis. If you guys want to, you can put your answers in the chat. It is up to you, but I will be back in 2 minutes or so, and we'll check your answers. All right, predict the products for these reactions. Again, combination synthesis, definitely one of the easiest ones. It can be more complicated, but not in chemistry 1120. So let's look at this. Potassium is obviously K, and it's a solid because it's a metal. Iodine is I2. This is a This would also be a solid, actually. So I don't know if this reaction would actually be really realistic to do in real life. How do I know that they're both solids? I go to my periodic table and I look at the color of the element on that periodic table. Now, I'm embarrassed now because I can picture the table in my head. I've been using the same table for 8 years, but I just needed to double check. Iodine on your periodic table is in a white square. Okay, so is magnesium. So these would both be solid, which leads me to believe this isn't really a realistic reaction, but I would get Ki, capital K, capital I, and this would also be solid. Now, one interesting thing here is you might look this up on the solubility chart, and it might say that it was aqueous. But aqueous only really happens if we have water. And there's no water here. There's no water in any of these elements. So technically, this would be solid. If you put aqueous down because you used your solubility table, I don't think I would take off marks. I would want to. I mean, you are wrong, but you know, if you're using your solubility table, that's fine by me. So the only thing left to do with this equation is to balance it. So I need to put a 2 here and a 2 here. And now I have a beautiful balanced equation. By the way, guys, if you don't know where Ki comes from, the charge on potassium is 1. The charge on iodine is -1. Perfect match for a chemical. You know, 1 potassium, 1 iodine go together. All right. I don't think I'm going to have much more time after this. I think we can do combustion, and then we might have to stop after combustion for today. But anyways. I also apologize if you guys can hear a lot of noise. The people above me are like doing some construction in their apartment, and my washing machine is going. So if you hear a lot of background noise, I do apologize. Abdullah has a good question. Do you have to write solid, liquid, gas, or can you just complete the reaction? Okay, let's be real. If you know, okay, actually, all right, let me tell you 2 things. I have 2 things very important to tell you. Thing number 1 is all of your tests have so far been online, which means you're entering your answers on D2L. So technically, for a full complete answer, I would need you on like if on D2L you had to write the product. Okay, so I just wanted you to type that in. You didn't have to balance it. You just wanted to type the product in. I would require sulfur solid for full marks. But if you didn't put in the phase, you'd only lose like maybe half of a mark or even less than that, maybe a quarter of a mark. So I do need this. The other piece of information I can tell you today, I just had a meeting at 12:30 about your final exam. Because Chemistry 1120 is such a large group, your final exam is online on D2L. So now that is only for Chemistry 1120. I don't know about your other courses. If you're in medical science, if you're in engineering or whatever program, I am only talking about chemistry. So Chemistry 1120 final exam is also online. So to answer your question, because your exams are online, I might want you to, or I do want you to put the phase in, but you wouldn't get a 0 if you didn't. All right, one more. Then we'll do combustion, and then we might have to stop for today. All right, this bottom one. Oh, and by the way, guys, I'll make a post on D2L about your final exam soon, just because I know not everybody is here today. So if you want more clarification on your final, I'll be posting that on D2L soon. I literally found out an hour ago. Okay, this tough example. Well, I say it's tough. It's only tough because you have to remember Unit 3. If I asked you to write the chemical formula for magnesium nitride, magnesium and nitrogen going together, what you would do is you would write down the charge on magnesium and the charge on nitrogen. Now, nitrogen is in group 5 or 15, 5A or 15, so it has a charge of -3. Magnesium is in group 2 or 2A, so it has a charge of 2, positive. All I need to do to write the formula is crisscross my charges. So my formula I end up getting for this compound is Mg3N2. So in the chat there, I think it was Abdullah or Abdulaziz. I don't have my chat open right now, but you put the number 2 twice. This 2 has nothing to do with my chemical formula on the other side. Okay, so don't put this 2 anywhere. That 2 only belongs to the product or the reactant side. So this again would be solid because there's no water in any of these equations, so it can't be aqueous. Okay, so the only thing left to do for full marks here is to balance my equation. And honestly, to balance this is pretty easy because all I have to do is put a 3 in front of the magnesium, and that's it. So this would be 3 magnesiums plus nitrogen gas would give me magnesium nitride, and everything is already balanced. Well, once I've put the 3 at the beginning. All right, guys, how do you feel about that? Are there any questions? If you have any questions, just let me know in the chat. I had to mute the mics because somebody kept leaving theirs on and it was really noisy. But if you have any questions, let me know. If not, I'm going to move on to one more reaction. One thing I'll mention is I have worksheets and answer keys created for chapter 5. I will upload those today. They're already done. I was just about to upload them before class, but I had that meeting. So if you guys want some practice on this, there will be worksheets on D2L today. There are also worksheets already uploaded weeks ago from chapters 3 and 4. So you can already get started looking at worksheets from chapters 3 and 4. I had a question in the chat earlier about somebody asked, let me just scroll up a little bit. Oh, it was a voice message. Somebody asked earlier, how do you know what to study? The worksheets are labeled by their sections. So if you want to review section 3.4 or you want to review section 4.1, the worksheets are all labeled by the relevant sections. So when you're working on your worksheets, you can always tell by the name of the worksheet what section you are reviewing. And as Shiraz just asked in the chat, will we have the whole day? Yes, I will give you the whole day on Thursday to do the test. You will have a 2-hour time limit. I'm giving everybody double time. So the test should only take 30, 40 minutes, but I'm going to give everybody 2 hours, so double time. And you can do the test anytime that day. You could do it 8 in the morning. You could do it 10 o'clock at night, as long as you have it submitted before 11:30, or I guess I could make it midnight. So as long as you have it submitted before midnight, it will work. Okay. All right, guys. So last part of today, and then I'll have to finish. How far will I get to this? Okay, no, this is fine. This is good. So one more reaction for today. We might do one more reaction tomorrow, and then we'll start our review. So we might not get every reaction done, but we'll get at least 4 of them done before your test. This is our last one, hydrocarbon combustion. Okay, this is completely different than the other 2 reactions, and this is honestly one of the easiest types of reactions because they are all the same. Hydrocarbon combustion involves compounds reacting with oxygen to produce heat. Okay, a hydrocarbon is defined as a chemical that contains carbon and hydrogen. So what I mean is, this is like when we burn things like methane or propane or butane. You guys do this all the time. If you ever light a lighter, or you have a barbecue or grill that has propane, even in your cars if you drive, or I'm sure you take public transit at some phase. These all revolve or rely on burning hydrocarbons, so things like octane or propane. The hydrocarbon combustion is always the same, and sorry, I'll write this myself because it's not really my text isn't lining up. A hydrocarbon combustion always reacts with oxygen and always produces carbon dioxide gas and water, always. So for a hydrocarbon combustion, you don't actually have to memorize, or you don't have to worry about ionic formulas or anything. When you take a hydrocarbon and burn it, combust it in the presence of oxygen, you always get carbon dioxide and water. This is what we would call complete combustion. We are not going to deal with incomplete combustion in this course. So to balance this, and we'll talk about balancing in a minute, I would put 6 here, 4 here, and 4 here. We'll practice this in a minute. I'll show you kind of how to balance this. Yaya mentions in the chat, what about coal? Coal is also a hydrocarbon. So it's a solid form, but yeah, coal, guys, even like burning a candle is actually typically burning a hydrocarbon. A candle is made out of paraffin wax, which is a big hydrocarbon. I have a private message here that says, when will the final be? We don't know the date yet, but it will be around the second week of December. So the final exam will be like classes end December 6th. So exams will be after that, the second week of December. So three to 4 weeks away at least. Well, 3 weeks away for sure. Okay, so the finale of today is to predict the products for these reactions and try to balance these equations. Now, some of these might be hard to balance. We'll see. So first things first, anytime you have a hydrocarbon, carbon and hydrogen, and you're reacting it with oxygen, every time in chemistry 1120, the products are always carbon dioxide, gas, because remember, we're burning this, and water gas. If you wrote water as a liquid, I would take that as well. But realistically, you need to remember that this is under high heat. We're burning, we're combusting these chemicals. So technically, everything is a gas because it's so high temperature. So guys, here's what I'm going to do. Well, it's 10 after 2. What I think we should do, because of time, I have to make sure I can get this covered in my other class as well. These are the products. What I would like for you guys to do is tonight, try to balance these equations. This can be kind of hard to balance. And then in tomorrow's class, we will balance these equations. We might very quickly look at one more reaction, and then we'll do review for your quiz, a test on Thursday. So guys, I'm going to stop recording here. I'll get your worksheets up in the next 10 minutes. And for tomorrow, see if you guys can balance these equations. So I've already predicted the products. I just need to balance these. Okay, these are hard. This is like about as hard as balancing gets. So I'm going to stop talking now. You guys have a fantastic day. Be safe, wash your hands, and we'll continue with this tomorrow. If you have any questions, you can let me know in the chat.